The students were started with the chapter amines, right? So what are amines? Amines are derived from ammonia, therefore you can call them as derivatives of ammonia. In fact, we have come up to the point where we are started with the methods of preparation. Right? So I'll just go through what we have done and then we'll finish all the methods of preparations. So first we saw was reduction of nitro compounds as correct. Right, so NO2 nitro plus you can use H2 RPD in C2H5OH, or you can use scrap ion, right? You can also use Sn plus HCl or Fe plus HCl. So this gives you aniline or aminobenzene. This was the first one. Then we had seen reduction of cyanides and the amines. Right? So cyanides or nitrides and amines. So what was that? R dash C triple bond N. Right? So you can use H2 bar nickel C2H5OH. So you can get CH2 in H2. This is your amine. Similarly, you can take an amine CONH2 with lithium, aluminum hydride and water. This is 1, this is 2, followed by hydrolysis. This can give you R dash CH2 dash NH2. So these are all reductions of either nitro or nitrides or amines. This we had already seen. Today we will go into the Gabriel synthesis. It is also called as the Gabriel thalamide synthesis. No? We use the compound thalamide. So what is thalamide? Thalamide is C double bond O dash C double bond O dash NH. So this is thalamide. This thalamide is made to react with ethanolic potassium hydroxide. Okay. So add KOH. What happens? You get the potassium salt of thalamide. So this is the potassium salt of thalamide. Okay. Now what you do? You react it with an alkyl halide followed by an alkaline hydrolysis to get your primary amine. So you can prepare primary amine using Gabriel thalamide synthesis. So the thalamide is treated with ethanolic KOH to get potassium salt of thalamide, and then it is reacted with an alkyl halide R-X. Okay. Then you have to do the alkaline hydrolysis. to get your primary amine. Okay, so this is your phthalimide synthesis. This Gabriel synthesis, which is also called Gabriel phthalimide synthesis. Start from phthalimide, convert that into potassium salt by adding ethanolic KOH, then treat it with alkali, follow it up with alkaline hydrolysis to get your primary amine. Okay, so this is now the fourth method of preparation, right? Okay. Then there is one more important method of preparation, that is the fifth one, and that is Hofmann's bromomide reaction. Hofmann's bromomide reaction. What is this Hofmann's bromomide reaction? It is also a method of preparation of primary amine using an amide. So amide is treated with bromine in ethanolic KOH to get your primary amine. Okay, so we start with amide, treat that with bromine using ethanolic KOH. That reaction is called as Hofmann's bromomide reaction. So we start with an amide R-CONH2. Okay, plus Br2 plus 4 times NaOH or KOH, whatever. And either is actually it is ethanolic alkali that has to be used, and either use KOH or you can use sodium hydroxide. So this will give you your primary amine R-NH2. Okay. Plus what do you get? You get 2 times sodium carbonate. Right? Sodium carbonate you will get. Plus 2, give it to bromine, you will get 2 NaBr. And you have 4 hydrogens here, so you get 2 H2O. This reaction is called, this is an amine. And we get a primary amine. Okay. So you can give an example for this. This is suppose CH3 dash COs and H2. Okay, now take it as C2 H5. So what do we get? You get C2 H5 dash and H2. Okay. So fifth one, Hofmann's bromomide reaction. Primary amine can be obtained by the reaction of amide using bromine in an alkaline solution. Then the sixth one, the sixth method of preparation is hormone analysis. you know the C-X bond, the C-X bond in alkyl or benzyl halide can easily be broken by a nucleophile. Okay. Therefore, the C-X bond of the alkyl halide can be broken using ethanolic solution of ammonia, okay, or ethanolic ammonia solution. Okay. So if you do that, it undergoes nucleophilic substitution reaction, and the C-X bond. Suppose if you react an alkyl halide with ethanolic ammonia solution, it will undergo nucleophilic substitution reaction in which the C-X bond will break and the halide or the halogen here will be replaced by NH2 group. Okay. So the breakage of the C-X bond using ammonia is called as homoanalysis. So what we do? We break this bond, okay, and replace this X by NH2 group. And to do that, what we do? We use ethanolic ammonia solution or solution of ammonia. Okay, so it's a nucleophilic substitution reaction, right? So the X minus or the X, the halide that goes up, is replaced by NH2 group. Okay. So in other words, we can say homoanalysis is nothing but breakage of C-X bond using ethanolic solution of ammonia or using ammonia. So normally what happens? If you have R dash and H2 plus if you add HX, so normally what you get? You get R dash NH3 dash X, and this is the salt. So what you can do is start with a primary amount. Okay. Add Rx to that minus Hx from that. So what will happen? You will get R2 NH. So what happens? The primary amine is converted into secondary amine. And now add one more Rx minus Hx. What do you get? You get R3N. So now primary to secondary to tertiary, right? So you have come from primary amine to secondary amine to tertiary amine. Now suppose if you have more Rx, you can go up till R4 N plus X minus. So till you get a quaternary salt. So this is your tertiary amine, this is your secondary amine, this is your primary amine. So this reaction is called as homoanalysis, breakage of C-X bond in an alkyl halide using ammonia. So it's a nice way of conversion of primary amine to secondary amine to tertiary amine to, then you get a quaternary salt. Okay, so this is homoanalysis. So I will summarize all the reactions again, right? Methods of preparation. First one, reduction. Then comes R dash C triple bond N in presence of H2 bar Ni C2H5OH, right? Now we can use what is that, sodium, amalgam and ethanol, CH2O5OH, right? So here also you will get R dash CH2 and H2. Then comes R dash CO and H2 in presence of lithium, aluminum hydrate and water. You get R dash CH2 dash and H2. Right. After that we learn the Gabriel. Cyanides synthesis. So we start with alimine, KOH, C double bond O dash C double bond O dash N K. Then we have alkali. That gives you R dash C double bond O dash C double bond O dash, and this to add NaOH, that gives you plus R dash and H2. I'm not write this in the primary amine. Okay. Then Hofmann's bromomide reaction. So what we do, we take an amine R dash CO and H2 plus Br2 plus 4 NaOH. That gives you R dash NH2 plus it gives you Na2CO3 plus 2NaBr plus 2H2O. Then hormone analysis. Ammonolysis. R dash 2NH2 piece of RX makes it R2 NH. RS gives you R3 N. RX gives you R4 and plus H times. Right, so this is the methods of preparation. Okay. Now coming to the properties, physical properties of amines. Now the lower aliphatic amines are normally gases. Okay, so lower ones are gases, but amines having carbon atoms 3 or more than 3, they are liquids, and higher members are solids. Okay. Normally lower aliphatic primary amines have a peculiar order. We say they have fishy order. So you can say lower members have fishy order. Okay. Now if you take for example the lower aromatic ones like aniline and others, they are colorless. Okay. But what happens due to atmosphere, if you expose them due to atmospheric oxidation, they will get some color. Otherwise normally pure aromatic amines, especially primary ones, are colorless in nature. Coming to their solubility, lower amines are soluble in water. They are soluble in water because, especially the primary amines, they can form hydrogen bonding with water. But what happens as the molecular mass of amine increases? Then what happens? The solubility goes on decreasing. So lower members are soluble, higher members become insoluble in water. Okay. Now if you take primary amines, and secondary amines, now they go in for intermolecular associations. Okay. The intermolecular associations is due to the presence of hydrogen as well as nitrogen. You know, nitrogen of one molecule can form a hydrogen bond with the hydrogen of the next molecule. So in case of primary amines and secondary amines, you know the formula being R dash N H2 and R dash N H dash R, there is hydrogen available, right? Therefore, this intermolecular association can take place because nitrogen of one molecule can form a hydrogen bond or make an intermolecular association connection with hydrogen of another. So in case of primary amines, the intermolecular association is seen. But if you take a tertiary amine, for example, it is R dash N dash R dash N dash R. You see that there is no hydrogen available. And because of this reason, the intermolecular association is not seen in tertiary amines. But in case of primary amines and secondary amines, this intermolecular association is seen, and it is purely because nitrogen of one molecule can form a hydrogen bond with hydrogen of another molecule. So depending upon the availability of these hydrogens, this association is possible. Okay. So these are in general the physical properties. Lower members are gases, lower members of aliphatic amines especially are gases, but those which have the carbon atoms 3 and above that, they are liquids, and the higher ones are solids. Okay. As far as the aromatic are concerned, they are colorless, okay, but develop color due to atmospheric oxidation. The lower members also have a fishy odor, okay. Then coming to their solubility, the solubility is there for lower members, they are soluble because of formation of the hydrogen bonds with water molecules. But as the molecular mass of the amine increases, what happens? The solubility goes on decreasing. So we say with increasing molecular mass, the solubility of amines decreases. Okay. Then as I told you, primary amines and secondary amines can go in for intermolecular associations due to the formation of bonds between nitrogen of one molecule and hydrogen of another molecule. Okay. With respect to chemical properties, we will deal with in the next class. Okay. So we have come up to physical properties, methods of preparation, physical properties. Next we will see chemical properties.